This week in the Rangeland Inventory Vegetation Monitoring class, we're going to do a project that is based on some monitoring data that was taken at the OX Ranch in Idaho. This ranch is located in kind of central northern Idaho along the western border, right along the Snake River. And this is a project that I was involved in. So this is Karen Launchbaugh. I had the pleasure of working on this project and collecting data in 2002 and 3. And then again in 2012, and these are the data that we'll use as a part of this module. A little bit about the OX Ranch before we get going. The ranch is about 130,000 acres, and it stretches from the Snake River on the west up to higher mountain elevations in the east. The land at the lower elevations near the river are mostly owned by the BLM. Higher up in elevation in the forest, of course, is owned by the Forest Service, and mixed throughout is private land and some state properties also. The plots that we will examine in this module are across all of those land ownerships. Initially, there were 21 plots that were established by the ranch's Coordinated Resource Management Group. So the ranch worked with several agencies and organizations to establish 20 plots in 1979 and 80. Over the years, a few of those plots have been lost, either by fire or they were just simply lost. We can't find them. So when this project was initiated by classes from the University of Idaho, we were able to relocate 14 plots. So that will be the plots that we're using for this project. If you want to explore these plots a little bit more, they're depicted on this map. And you can see this map by going to your web browser and entering goo.gl/YLOJTQ, and the Q is capitalized. So again, goo.gl/YLOJTQ. This project was a collaboration between the OX Ranch and the Forest Service and Bureau of Land Management. The plots were read by those folks again in 1980s and 90s. Again, they were established 79 and 80. They were reread again in the late 80s and early 90s. And in 2002 and 2003, students from the University of Idaho relocated the plots. I had the pleasure of meeting John Dyer, who was the ranch manager at the OX Ranch, and he asked if my students would be willing to come out and help them out and look for those plots again and read them. So we read them first in 2002 and 3. Another class read them in 2006 and 2007. And again, a larger class read all of the plots in 1 year in 2012. This project, as it was set up by the OX Ranch, was simply to look at how changes in vegetation might be responding to their grazing management practices. They were also interested in how fire might be changing the vegetation, because fire is certainly a common thing on these landscapes. Their general overall goal was to hopefully increase perennial grass cover and minimize annual grass cover. The data methods are pretty simple for this project. They established first photo monitoring plots at these 20 plots. We have permanent ground plots that are like the square on the left that are 3 foot by 3 foot squares. They also established 30-meter transects. That's about 100 feet line transects. Transects bent in the middle, so they're kind of L-shaped transects with a 90-degree bend right at the 15-meter mark. Along those transects, technicians read the basal cover of grasses, forbs, and shrubs. They used basal cover because it's a measure of vegetation that's not very susceptible to yearly changes in precipitation or in changes such as grazing. So it's a really conservative measure of the plant composition, a fairly stable measure of plant composition on the ground. So it's a good one to use when you're doing long-term monitoring plots, because you'll be able to track changes in the community without really being influenced so much by annual variation in precipitation. When the students got done reading the data, they came back to the lab and they entered all of the data. They used 4-letter species codes, and they calculated the percent cover of annual grasses, perennial grasses, forbs, and browse, simply by looking at how much of each species was occupied along that 30-meter transect and calculating a percentage cover. For this module, you will be given the percent cover and asked to look for differences. So the question that is before you in this assignment is to see if perennial grass cover and annual grass cover has changed from the data set that was collected in 2002 and 3 to the data set that was collected in 2012. So we want to know what happened over that decade, and that's the challenge that's ahead of you. So go ahead and take a closer look at the message or the assignment details and calculate and see if there's a difference.